Welcome friends. In this module we discuss correlation and regression analysis. Regression lines. For two variables x and y which are numerically measurable in nature, we know correlation analysis determines the degree of relationship between x and y provided the relationship is linear, but the regression analysis establishes the nature of linear relationship between the variables. Let x1 y1, x2 y2, etc. x n y n be the set of observations obtained on the two variables x and y. Let us plot a scatter diagram of these points. The line about which the points in the scatter diagram cluster is called the regression line, and the equation representing this line is called the regression equation. There are two approaches for finding the regression line. One is fitting a straight line of the form y equal to a x plus b to the given data x 1 y 1, x 2 y 2, etc. x n y n. By fitting of a straight line of the form y equal to a x plus b, we mean estimating the best values of a and b using the given set of observations. By the principle of least squares, the best values of a and b are obtained as minimizing the sum of squares of possible errors in y values. The other is fitting a straight line of the form x equal to c y plus d to the data by minimizing the sum of squares of possible errors in x values. If all the given x I y a values are perfectly obeys a linear relation, then the straight line is fitted by the above two approaches will be same. But in general, the x I y a values may not perfectly obey a linear relation, and hence the above approaches may give two different straight lines for the given data. The straight line fitted to the data in the form y equal to a x plus b by minimizing the sum of squares of possible errors in y values is known as the regression line y on x, and the straight line fitted to the data in the form x equal to c y plus d by minimizing the sum of squares of possible errors in x values is known as the regression line x on y. Using the principle of least squares, the regression line y on x of the form y equal to a x plus b for the given data x 1 y 1, x 2 y 2, etc. x n y n is derived as y minus y bar equal to covariance between x y divided by variance of x into x minus x bar, and the regression line x on y is derived as x minus x bar equal to covariance of x y by variance of y into y minus y bar. Equations of regression lines or regression equations show a relationship between the average values of two variables. In that way, regression equations are very helpful in estimating and predicting the average value of one variable for a given value of the other variable. The regression equation x on y is usually used to predict the average value of x for a given value of y, and the regression equation y on x uses to predict the average value of y for a given value of x. Regression coefficients. In the regression line y on x, the coefficient of x, covariance of x y divided by variance of x, that is p x y by sigma square x, is known as the regression coefficient of y on x, denoted by b y x. And in the regression line x on y, the coefficient of y, covariance of x y divided by variance of y, that is p x y by sigma square y, is known as the regression coefficient of x on y, denoted by b x y. The regression line y on x help to predict the value of y for a given value of x, and the regression line x on y helps to predict the value of x for a given value of y. Properties of regression coefficients. 1. The two regression coefficients are with same in sign, both positive or both negative. Covariance of x y decides the sign of regression coefficients. According to the sign of covariance of x y, the regression coefficients becomes positive or negative. 2. The geometric mean of these regression coefficients gives the absolute value of the coefficient of correlation Rxy. The sign of correlation is determined by the sign of regression coefficients. If the regression coefficients are positive, Rxy is positive in sign, and if regression coefficients are negative, Rxy is negative in sign. 3. If one regression coefficient is greater than unity, the other is less than unity. Problem. Find the regression lines and calculate the coefficient of correlation for the following data on x and y. Also predict the value of y corresponds to x equal to 17. X values 6, 5, 7, 8, 9, 10, 12 and 14. Corresponding y values 5, 5, 6, 9, 10, 12, 13 and 14. Solution. The regression lines are y minus y bar equal to pxy by sigma square x into x minus x bar and x minus x bar equal to pxy by sigma square y into y minus y bar. To find x bar, y bar, pxy, sigma square x and sigma square y. Pxy equal to 1 by n summation over I from 1 to n xi yi minus x bar y bar. Sigma square x equal to 1 by n summation over I from 1 to n xi square minus x bar square, and sigma square y equal to 1 by n summation over I from 1 to n yi square minus y bar square. The calculations are as follows. X values 6, 5, 7, 8, 9, 10, 12 and 14 with a sum 71. Y values 5, 5, 6, 9, 10, 12, 13 and 14 with a sum 74. X square values 36, 25, 49, 64, 81, 100, 144 and 196 with sigma x square 695. Y square values 25, 25, 36, 81, 100, 144, 169 and 196 with sum of yi square values 776. X into y values 30, 25, 42, 72, 90, 120, 156 and 196. Sigma xy equal to 731. X bar equal to 1 by n sigma xi, that is 1 by 8 into 71, that is 8.875. Y bar equal to 1 by n sigma yi, that is equal to 1 by 8 into 74, that is 9.25. Pxy, that is 1 by n into summation over I from 1 to n xi yi minus x bar y bar, that is equal to 1 by 8 into 731 minus 8.875 into 9.25, that is equal to 9.28. Sigma square x equal to 1 by n into summation over I from 1 to n xi square minus x bar square, that is equal to 1 by 8 into 695 minus 8.875 the whole square, that is equal to 8.5525. Sigma square y equal to 1 by n summation over I from 1 to n yi square minus y bar square, that is 1 by 8 into 776 minus 9.25 the square, that is 11.44. Hence, the regression line y on x, y minus y bar equal to pxy by sigma square x into x minus x bar is y minus 9.25 equal to 9.28 divided by 8.5525 into x minus 8.875. This implies 1.085x minus y plus 0.335 equal to 0. The regression line x on y, x minus x bar equal to pxy by sigma square y into y minus y bar. This implies x minus 8.875 equal to 9.28 divided by 11.44 into y minus 9.25. This implies x minus 0.811y plus 1.372 equal to 0. Coefficient of correlation Rxy equal to pxy by sigma x sigma y, that is equal to 9.28 divided by square root of 8.5525 into square root of 11.44, that is equal to 0.938. We can use the regression line y on x to predict the value of y for x equal to 17. The regression equation y on x is y minus 9.25 equal to 9.28 divided by 8.5525 into x minus 8.875. For x equal to 17, y minus 9.25 equal to 9.28 divided by 8.5525 into 17 minus 8.875. This implies y equal to 9.28 divided by 8.5525 into 17 minus 8.875 plus 9.25. This implies y equal to 18.07. Problem. The following are obtained from the age x and systolic pressure y data of 10 individuals. Means of x and y values 56 and 140 respectively. Variances are 140 and 160 respectively. And summation over I, xi minus x bar into yi minus y bar equal to 1320. Using appropriate regression equation, estimate blood pressure of an individual aged 50. Solution. To predict y value for a given x value, the regression equation y on x is appropriate. This line is expressed as y minus y bar equal to pxy by sigma square x into x minus x bar. Here pxy equal to 1 by n summation over I xi minus x bar into yi minus y bar equal to 1320 divided by 10, that is 132. Hence, the line becomes y minus 140 equal to 132 by 140 into x minus 56. When x equal to 50, y minus 140 equal to 132 by 140 into 50 minus 56. This implies y equal to 132 by 140 into 50 minus 56 plus 140, that is 134.34. Angle between the regression lines. The regression equations are y minus y bar equal to pxy by sigma square x into x minus x bar and x minus x bar equal to pxy by sigma square y into y minus y bar. Since Rxy equal to pxy by sigma x into sigma y, the regression coefficient y on x pxy by sigma square x equal to Rxy into sigma y by sigma x, and the regression coefficient x on y pxy by sigma square y equal to Rxy into sigma x by sigma y. Hence, the regression equations are y minus y bar equal to Rxy into sigma y by sigma x into x minus x bar, let it be 1, and x minus x bar equal to Rxy into sigma x by sigma y into y minus y bar, let it be 2. The regression equation x on y can be rewrite as y minus y bar equal to sigma y by Rxy into sigma x into x minus x bar, let it be 3. Now, the regression equation y on x, equation 1, and that on x on y, equation 3, can be written in the form y equal to mx plus c as follows. Y equal to Rxy into sigma y by sigma x into x minus Rxy into sigma y by sigma x into x bar plus y bar, that is 1, and y equal to sigma y by Rxy into sigma x into x minus sigma y divided by Rxy into sigma x into x bar plus y bar, that is equation 3. From here we get the slopes of these two regression lines as m1 equal to Rxy into sigma y by sigma x and m2 equal to sigma y divided by Rxy into sigma x. Let us consider theta as the angle between the regression lines. Using the slopes of the regression lines, it can derive tan theta equal to plus or minus r square xy minus 1 by Rxy into sigma x into sigma y divided by sigma square x plus sigma square y. If Rxy equal to plus or minus 1, we get tan theta equal to 0. This implies the angle between the regression lines theta, that is tan inverse 0, equal to 0. That is, if there is a perfect linear relation exists between x and y, whether it is direct or inverse, the angle between the regression lines is 0. Or in other words, the two regression lines coincide or they are same. If Rxy equal to 0, we get tan theta equal to infinity. This implies the angle between the regression lines theta equal to tan inverse infinity, that is equal to 90 degree. That is, if there is no linear relation exists between x and y, the two regression lines are perpendicular. If there are two regression lines, it is obvious that they are intersecting at a point. By solving the regression equations, the point of intersection of the regression lines is obtained as x bar y bar. Identification of regression lines and determination of correlation coefficient. If we are given a1x plus b1y plus c1 equal to 0 and a2x plus b2y plus c2 equal to 0 as the two regression lines, it is to identify which of them represent regression line y on x and which is regression line x on y. For this, first of all, we assume the first line a1x plus b1y plus c1 equal to 0 is the regression line y on x or regression line x on y. Let us assume the first line is regression line y on x. Then we express the line in terms of y as y equal to minus a1 divided by b1 into x minus c1 divided by b1. Then the regression coefficient y on x is byx, that is equal to minus a1 divided by b1. If the first line is assumed as regression line y on x, the second is regression line x on y. It is written in terms of x as x equal to minus b2 by a2 into y minus c2 by a2. If so, the regression coefficient x on y bxy equal to minus b2 divided by a2. We know the geometric mean of regression coefficients is the magnitude of coefficient of correlation rxy and minus 1 less than or equal to rxy less than or equal to plus 1. Hence, if square root of byx into bxy, that is equal to square root of a1 by b1 into b2 by a2 less than or equal to 1, we can confirm that our assumption regarding the regression lines are true. Otherwise, the first line is the regression line x on y and the second line is the regression line y on x. Then the regression coefficients are bxy equal to minus b1 by a1 and byx equal to minus a2 by b2. Then the coefficient of correlation rxy equal to square root of a2 by b2 into b1 by a1, which is the reciprocal of rxy obtained by previous assumption. Problem. The equations of two regression lines obtained in a correlation analysis are 8x minus 5y plus 14 equal to 0 and 24x minus 7y minus 5 equal to 0. Number 1, identify the regression lines. Number 2, obtain mean of x and mean of y. 3, find rxy. Solution. Number 1, let us assume the first line 8x minus 5y plus 14 equal to 0 is the regression line y on x. It can express as y equal to 8 by 5 into x plus 14 by 5. This gives byx equal to 8 by 5. Then the second is the regression line x on y, which is expressed as x equal to 7 by 24 y plus 5 by 24. This gives bxy equal to 7 divided by 24. Geometric mean of byx and bxy is square root of 8 by 5 into 7 by 24. That is equal to square root of 56 by 120. That is square root of 0.467. That is equal to 0.683, which is less than 1. Hence, our assumption is correct. That is, the line 8x minus 5y plus 14 equal to 0 is the regression line y on x and 24x minus 7y minus 5 equal to 0 is the regression line x on y. Number 2, the means of x and y is obtained by solving the regression equations for x and y. 8x minus 5y plus 14 equal to 0 and 24x minus 7y minus 5 equal to 0 are the regression equations. Hence, 8x minus 5y plus 14 equal to 0, let it be number 1, and 24x minus 7y minus 5 equal to 0, let it be number 2. Equation number 2 minus 1 into equation number 3 implies minus 7y plus 15y minus 5 minus 42 equal to 0. This implies 8y equal to 47, that implies y equal to 5.875. Put y equal to 5.875 in equation number 2. We get 8x minus 5 into 5.875 plus 14 equal to 0. This implies 8x equal to 15.375, that is x equal to 1.923. Hence, the means of x and y are respectively 1.923 and 5.875. 3. Geometric mean of the regression coefficients gives the magnitude of the coefficient of correlation. Here, the two regression coefficients are of positive in sign. Hence, the coefficient of correlation rxy equal to plus 0.683. Problem. Given that 12x plus 10y minus 3 equal to 0 and 11x plus 20y plus 9 equal to 0 are the regression lines for x and y. Identify the regression lines and find the correlation coefficient. Solution. Assume that 12x plus 10y minus 3 equal to 0 is the regression line y on x. Then y equal to 12 by 10 into x plus 3 by 10. This implies the regression coefficient y on x equal to minus 12 by 10, that is equal to minus 7 by b1. The line 11x plus 20y plus 9 equal to 0 is assumed as the regression line x on y, then x equal to minus 20 by 11y minus 9 divided by 11. Then the regression coefficient x on y equal to minus 20 by 11, that is equal to minus b2 by a2. Then square root of a1 b2 divided by a2 b1, that is equal to square root of minus a1 b1 into minus b2 by a2, that is equal to square root of minus 12 by 10 into minus 20 by 11, that is equal to 1.477, which is greater than 1. Hence, our assumption about the regression lines are not true. Now, 11x plus 20y plus 9 equal to 0 is the regression line y on x, and the line 12x plus 10y minus 3 equal to 0 is the regression line x on y. Then y equal to minus 11 by 20 into x minus 9 by 20, and regression coefficient y on x equal to minus 11 by 20, that is minus 7 by b1, and x equal to minus 10 by 12y plus 3 by 12. The regression coefficient x on y equal to minus 10 by 12, that is equal to minus b2 by a2. Then square root of a1 b2 divided by a2 b1, that is equal to square root of minus 11 by 20 into minus 10 by 12, that is 0.677. Since the regression coefficients are negative, the correlation coefficient is minus 0.677. Let us summarize what we have discussed. The method of analyzing the nature of linear relation between two variables which are considering together is introduced in this module. Two approaches of regression lines are discussed. Properties of regression lines and the relation between regression coefficients and correlation coefficient are illustrated. The method of identifying two regression lines are also discussed and illustrated through numerical examples. Before you attend the next unit, please try to answer the following questions. Obtain the regression lines from the following data on humidity x in the storage place and moisture content y in percentage for a raw material over 10 years. Also predict the value of y for x equal to 22. X values 36, 42, 25, 37, 48, 39, 42, 47, 39 and 41. Y values 11, 13, 7, 9, 14, 12, 12, 14, 10 and 12. Next, two regression equations obtained from a given data are x equal to minus 0.2y plus 4.2 and y equal to minus 0.8y plus 8.4. Obtain number 1 x bar and y bar, and number 2 rxy. Next, height and weight of 10 individuals are noted as follows. Height x values 128, 145, 138, 154, 165, 167, 176, 169, 178 and 174. Corresponding weights y values 48, 59, 50, 52, 61, 66, 72, 65, 77 and 69. Obtain the regression equations x on y and y on x. Also predict the height for an individual with weight 55 kilograms. Books for your reference are 1. Marcelo Pagano and Kimberly Guerrio, Principles of Biostatistics, Signage Learning. 2. Mehdi J, Statistical Methods and Introductory Text, New Age International Private Limited. 3. Bud B.R., Sri Venkatramana T and Madhav Rao K.S., Statistics, a Beginner's Test, New Age International Private Limited. 4. Gupta S.C. and V.K. Kapoor, Fundamentals of Mathematical Statistics, Sultan Chand and Sons. 5. Daniel W. Biostatistics, John Wiley Sons. Hope you enjoyed this session. See you next time. Until then, goodbye.